Hello everyone, we're from Group 2 and we're here to present about Lake Toba. There's the lesson outline. So Lake Toba is a large volcanic lake in North Sumatra formed by supervolcanic eruption approximately 74,000 years ago. It is one of the most explosive events in geological history, and its latitude is 2.4254.3 north. Its longitude is 98.42.58.1 east. So here's the geological map of Lake Toba. We've traced the line. So here is the location. It's the cross section of A to B. So the distance cross section A and B we've calculated after measuring with a ruler. So it's 14.5 centimeters of 30 kilometers, and its length of line is 40 centimeters. Hence, the actual distance of point A to B is 40 centimeters times 30 kilometers, which is 14.5 centimeters times the actual distance. So the actual distance is 82.8 kilometers. This is the geological cross-section of A to B. The cross-section runs across the eastern margin of Lake Toba's caldera, starts on gently elevated volcanic terrain made mainly of thick Toba tuff deposits from a massive eruption 74,000 years ago. And moving towards the lake, the land drops sharply, showing lake margin sediments formed after the caldera filled with water. So further along, the section crosses major faults that shape the caldera's southeastern uh, boundary, causing uplift and tilting. Near the end, older basement rocks and younger volcanic deposits appear, forming the steep caldera wall. So overall, this section highlights thick volcanic layers, steep vaulted caldera edges, and lake sediments, all key features of Lake Toba's volcanic caldera. Next, we have hazard map of Lake Toba. This is the hazard map, and we have the red zone. The main risk here is volcanic eruptions, strong earthquakes, and landslides. We have the orange zone, which is the main risk are moderate earthquake damage, localized landslides, tsunami-like seisures. For the color yellow, the main risk are light to moderate ground shaking, minor flooding from lake waves, and low likelihood of large landslides. For the green color on the map, the main risk are seisures. Earthquakes can create oscillating waves inside the lake, much like a mini tsunami, a shoreline erosion, and floating debris hazards after landslides.
So for the topographies of Lake Toba sits inside of one of the largest volcanic calderas in North Sumatra, formed by a massive super eruption 74,000 years ago. The landscape is dominated by steep caldera walls, high volcanic ridge, and broad plateaus that form part of the Bukit Barisan Mountains. Elevation around lake range from 900 to 1400 meters, while surrounding peak rise above 2000 meters. At the center, Samoset Island represents a resurgent domain uplifted block of land pushed upward by magma after the eruption. Lake Toba itself lies about 900 meters above sea levels and reaches depth to up to 450 meters, creating the largest volcanic lake in the world. For the rocks and geological formation in Lake Toba, the region is primarily composed of volcanic igneous rock produced during and before the Toba super eruption. The most dominant unit is the Toba tuff, a thick sequence of hollow tuffs, pumice deposits, and ignimbrite flows that were in place during 74 Ka eruption. High silica volcanic rocks such as rhyolite and dacite appear along the caldera rims and within some uplifted blocks containing visible crystal of quartz and feldspar. Beneath the younger Toba deposit lie older basaltic and andesitic lava flows which form the basement of the caldera. The lake basin also contains layers of modern sedimentary deposit, fine volcanic ash, silt, and clay that accumulated after the eruption. And for the minerals in the area, the minerals reflect the high silica nature of the Toba magmatic system. Quartz and feldspar, which is orthoclase and plagioclase, are abundant in rhyolite and tuff units. Biotite and amphibole appear in willow tuffs and andesite, while pyroxene occurs mostly older andesitic and basaltic rocks. The eruption produced vast amount of pumice and volcanic glass, including obsidian fragments, which are commonly found around the caldera margins are and in aerated deposits. Overall, the Lactober region showcase a combination of dramatic volcanic topography, young and highly explosive volcanic deposits, and a range of mineral typical of large silicic caldera system, making it one of the most significant volcanic geological sites on Earth.
Here are the active tectonic plates around the Lake Toba. First, we have the Indo-Australian plate. So the Indo-Australian plate subducts northward beneath western Sumatra along the Sumatra subduction zone, and it's the main source of the earthquakes of the west coast of Sumatra. And next one, we have Eurasian plate, which is where the Lake Toba belongs to. This plate receives forces from the Indo-Australian plate, as mentioned before, and the entire region of Sumatra is responding to the convergence happening from the Indo-Australia plate.
So now we go into the geological structure in Lake Toba. So the first one we have thick volcanic layers, which is the section traverse gently elevated volcanic terrain composed primarily of thick Toba tuff deposit, which are the product of massive eruption approximately 74,000 years ago. The Toba tuff is the most dominant unit in the region, consisting of welded tuffs, pumice deposits, and embedded flows. Second, we have caldera sharpening faults, which is major faults are crossed along southeastern boundary of caldera. These faults were instrumental in shaping the caldera, causing uplift and tilting the surrounding blocks. This is consistent with the tectonic setting along the Sunda subduction zone. Third, we have the steep faulted caldera's edges. The land drops sharply toward the lake, revealing the steep caldera's wall formed by older basement rocks and younger volcanic deposit. Fourth, we have lake sediments. Closer to the lake, the section shows lake margin sediment that formed after the caldera filled water. Fifth, we have the Resurgent domain. Although the specific cross-section details mainly the eastern margin, the Lake Toba system in general is characterized by the Samosir Island Resurgent Dome.
So next up, it will be about the activities that we can find in the plate or in Lake Toba. So the first activities that we can find is boat and ferry trips, since people ride boats or ferries to explore the lake, especially to visit Samosir Island in the middle of the lake. Next will be swimming and water activities, such as like tourist swim, like kayak, or you just relax near the lakeside. Next up will be sightseeing and photography. So since Lake Toba is surrounded by mountains and cliffs, making it a popular spot for sunrise and sunset watching, and even panoramic photography. Next up will be visiting Piso Waterfall, which is a famous 120-meter waterfall on the north side of the lake. Number five will be about the cultural tourism, which visitors explore Batak culture, like such as the Batak house, dance performances, and local traditions, crafts, and souvenirs. And lastly will be about hiking and nature exploration, since there are a lot of mountains, hills, and viewpoints around Lake Toba, and it is great for trekking and nature walk. And lastly, it will be about the disaster mitigation in Lake Toba. So first, reforestation and forest protection. So by planting trees to prevent landslides, soil erosions, and forest degradation. Second will be safety programs for boat travel. by distributing life jackets, educating boat owners on safety warning systems for bad weather. And number three will be waste management programs by keeping the lake clean through cleaning campaigns and waste sortings and also community awareness programs. And number four will be about monitoring weather and geological activity. The authorities monitor rainfall, possible landslides areas, and volcanic activity near Lake Toba. And then number five will be community education by local communities are trained on emergency response, first aid, and evacuation plans for landslides or fires. And lastly will be about the sustainable tourism development by ensuring tourism does not damage the environment while supporting local communities. And I think that will be it for our presentation. Thank you for listening.